Okay, good morning, class. Today we are going to discuss lab 4, which is the first lab in Java. This was kind of a special tutorial because we will go through a few steps we need to do in our current environment to make sure we get Java working correctly, which I will be doing with you just to make sure we avoid any problems you guys might face similar to lab 0. So I will do all the steps with you one by one, and then hopefully this shouldn't take too much time because we really need only a couple of easy steps, and then afterwards we can start discussing the lab itself. Good? Maybe before this, again, let's do the usual thing and make sure if you guys have any questions in 2 minutes or so, let me try to answer these on the chat. So today is the deadline to submit.
There's a quick question I have. Sorry to interrupt.
Sure, yeah.
3 question 2. In the file it says you need to test 3 withdraw, like you need to withdraw 3 times. So do we have to do we do that 3 times or just once?
No, just once is okay. Yeah.
Okay. Thanks so much.
Yeah, thanks. So generally, like the rule for anything we have in all the labs is you should write a test case. So you should test every function you write at least once, additionally to the tests we give you. Do you do this as a separate test case, or do you combine multiple functions in the same test case? Well, it's better to add at least one single test case for each function, okay? So take this as a rule for all the labs, even for the Java labs as well, okay? Good. So let's start. What do we need to do? So really we have almost 95% of the environment we need. I guess there is a question before we start. For the withdraw function, if the student isn't found, do we still make a print statement like the lab sheet says? So if the student is not found, so you only return. So let me try to remember, because honestly I don't remember. Does the withdraw function return anything?
No, it's void.
No, void. So that means if you don't find it, I would say don't print. If you print, that's fine, but let's avoid, again, as a general rule, let's avoid any print in labs. And simply just do nothing. If it's not there, just do nothing, okay? Okay, good. So yeah, so let's make sure we start. Otherwise, the time will not be enough to discuss both the lab and the environment, and then maybe I will revisit the questions afterwards. Good. So what do we need to do? As I said, we have 95% of the environment. We need to do 2 main things. We already installed Java JDK, which is, as you know from the first lecture, is the Java virtual machine that enables you to run Java code into your own operating system and hardware. Good. So we already have this from Lab 0, because whether you know or not, really Eclipse native programming language is Java, right? So this is why we needed JDK even if we were doing C programming. Good. So we already have the JDK installed from Lab 0. So what are the 2 things we need? The first one is we need to install the packages for Java, because what we have done before is are the packages for the C, which is the C IDE. And the way to do this is to go to eclipse.org. I hope you are seeing my screen. Please comment otherwise. So you'll go to eclipse.org/downloads, the same thing we have done for Lab 0. And then now going to packages, instead of selecting the IDE for C, C++, similar to what we have done in previous labs, you should select the IDE for Java developers, okay? If you do this, select your operating system, download yours. It's like going to take a couple of minutes. And then after you do this, let me share with you what we have here, downloads inside. Okay.
Can I ask a question?
Sorry, give me a second and then I will take questions just to make sure we are following the flow of what we need to do, right? So I hope now you are able to see my Explorer, because sometimes Zoom has problems with, so you guys are able to see my window, right?
Yes.
Okay, good, thanks. So once you download this, you will find a file called Eclipse Java 2020, whatever the version it is, and it's a zip file. And then you just extract it, you go inside. the easy thing here is really for Java IDE, you don't need to install. It's really, if you just, there is the XE file there, at least this is the way for Windows and for Linux, the two operating systems that I was able to test. And I believe maybe 95% is also the same way for Mac OS. So once you double click this, you are able to run your Eclipse, good? For Java IDE, as we will see right now. But you need one extra step for this, right? I said we already installed the Java JDK in Lab 0, but one thing we didn't do is to add the JDK path into our operating system path. We have done this for the MinGW or I guess the cross GCC for Mac OS, but you have to do this also for the JDK for the lab. So how to do this? Let me go back to my Explorer here, and then I will be sharing all these things with you, okay? Like written in the lab document or associated documents in the lab folder, but I just wanted to go through with that to make sure you guys know how to do it, good? So the step we are missing here is to add it into our repo. So we have already installed Java JDK, otherwise you will not be able to do your labs. The only thing you need to do is you need to add it to your path. Let's see how to do this here. As an example, this is Mac OS, this is Windows, I guess. And for Windows, okay, so for Windows, you need to add it. If you remember what you have done for the MinGW for Windows, for example, or the C toolchain in general for whatever operating system, you have to add the path for the binary in your like operating system main path, right? So what we need to do is to add the directory of the Java JDK, which you already have installed in this directory if you have done Lab 0 correctly. I guess you will not be able to see now my libraries, but I will just open them and then share them with you. Advanced system settings. Let me see. Okay, if you just write in the search box advanced system settings, open. I'm not sure if you're able to see, but let me, okay, here. I guess now you are able to see my system properties window, right? So if you remember this window from Lab 0, again, we have done this for the MinGW or C toolchain, and we added this into the environment variables, right? So again, I'm not sure if you're able to see my environment variables.
We are.
Oh, that's good. Yeah, usually it's not. And then what you need to do is follow the same steps we have done to add the path here. So you do the path and then edit. Oh, now I remember that it doesn't enable you to open the edit if you are sharing. But simply you will do edit, and then you will find another window that you need to add the path of your Java JDK, which is usually C program files Java JDK version /pen in Windows. I guess a similar thing for Mac OS as well. Good. So the step is very easy. What you need, like the main purpose of doing this is to make sure when you try to launch Eclipse, it knows by default where Java JDK is located. Otherwise, it will not be able to open. Good. Assume we have done this step correctly. I guess I need to stop sharing. Otherwise, I cannot proceed. And then let me reshare that. Okay, going back here, if you have done this step correctly, you should just by double click on the eclipse.exe, it will open the Eclipse IDE for you, which keep hoping, but hopefully. Okay, so now we should be able to see my Eclipse IDE for Java. Good. So to summarize, you download the Eclipse IDE for Java. It already has the executable, so you don't do any setup. And then you add the JDK binary path into your operating system library path, right? And instructions will be provided, and you have really done this in Lab 0 anyway for the C toolchain. Good. So now I'm kind of assuming we already have the Eclipse IDE for Java installed and open, but we didn't do anything yet. So how to create a Java project and how to proceed with the lab, right? So what you need to do is file and then import. And then like exactly same process, get project from get, you will get a link for your, I'm not sure if the other window, do you see the other window, the get importing one?
Yes.
Oh, that's good, thanks. So, and then you just clone URI and you do like you put the URI in the invitation link in the lab document here, and you will see it as usual. Because I have it on my machine as well, I'm going to import it directly from my machine. So I'm going to say import, and then now it's not from get, it's from existing project in workspace, and I should do this one to show you the steps. Okay, so once you import it as usual, nothing changed from the C labs, you should have the project open. Let me close every other project here. Close project, and then this one as well. Okay, so once you do this one, you might end up facing some errors, which I will let you know why now, and this is the main reason why I'm doing this with you. Simply in Java, we are doing the testing similar way, or similar, I would say, the same concept behind unit testing in C. We do it in Java, but in an easier way, because Java in Eclipse has already an inherent tool or like an internal tool that is called G-unit testing. So we don't need an external library here. And it's really done in a much easier way through Eclipse. And G-unit already comes installed with the Eclipse IDE for Java that you do. So you don't need to do anything extra, right? But the point is, when you clone your project, it doesn't have the G-unit library added by default. So what you need to do is, once you have the project open as I have right now, you need to say file and then new, and then select a G-unit test case, right? By selecting a G-unit test case, I mean, really it can be anything. Let me just make sure I select, for example, the matrix tests one, and then file, new, and then G-unit test case. And then you just hit finish. It will add another file for you. Feel free to delete this file because we already have our own test cases. What we needed instead is this, yeah, continue. What we need instead is this one, like the G-unit. Do you see here now the G-unit 5 is added already, right? And this is really what we are after in our lab, right? So what are these errors here? Yeah, because I guess you will not find this. Let's say I'm returning -1 here. So these errors will not be there. But once you do this, maybe I just open this project instead because it has the correct one. So the main step that you would need to do after you import the project is just to make sure you do this file, new, and then G-unit test case. And by this, Eclipse will add the G-unit library in your project folder, which is G-unit 5. So once you have G-unit 5, you are able to run the tests, right? So for example, here we have I will go through the files right now and what we need to do and what are the methods or functions. But simply, we run it exactly the same way. Right click and then run as, and then now instead of selecting Java application, if you select G-unit test, Eclipse will go through all the tests one by one and run them for you. And really it will show you this graphical interface. I hope you are seeing it. That tells you how many tests did you run, which ones are failing, which ones are passing, and like the passing ones will be green, similar to this one here, the test about triangular. And the failing ones, it tell you, if you go here, it will tell you, go down in the detailed message, it will tell you what is expected and what is the output. For example, here it's expected invalid index, but was empty for now. Nothing is getting implemented. So similar to what we have been seeing in C, but in C, to be able to do this, we needed to, I myself needed to add a library, write the test cases in a specific way to conform to the library, in, like add the library with the code itself in a certain way. In Java, it's much easier because testing is integrated with the program itself, and the JUnit is the one that is handling everything here, and you're able to see it visually, test case one by one, how much time it takes, whether it fails, it has X, or if it passes, has this check green mark. Good. So this is all about the environment. So if you got, sorry for I guess there was a question that I interrupted. If you got questions, you can ask now, because this is all for environment. We will now move to the lab itself, if or what we need to do for the lab, if we are good with the environment. So let me take questions. Okay, I will look into the chat, but feel free to enable your mic and talk if you wish. Okay, all of these are lab 3 questions, so I'm leaving them for now. May you remind what you do after you download the file. So Yanhao, so after I download, I guess when downloading the file, you are referring to the Eclipse IDE for Java. After I download it, I just extract it, go inside it, and then double click on the eclipse.exe. But if you do this directly without adding the path for the Java JDK into your operating system, it will complain to say, oh, Java JDK is not installed. While we really have it installed from lab 0, but you need to add the path to the operating system to let Eclipse know where Java JDK is. So once you download the file, maybe leave it for now, do the step of adding the Java JDK into your operating system path, and then you can double click the eclipse.exe file. So Yanhao, for the path, no, what we have set in C++ was really the path for the C tool chain, which is MinGW for Windows, for example. But now we should add the path of the Java JDK as well. All the instructions will be posted and written. Yeah, that's correct. And the video as well will be posted. Arjun, for Linux, the instructions are almost exactly the same. I have done both on my machine, and both are almost exactly the same. You download the Eclipse IDE, Java JDK path is already added by default for Linux, so you shouldn't care, but also the instructions for Linux will be posted. That's correct. Sky, will you post the video? Yeah, I will post all of that. Okay, good. So it seems that no more. Okay, so one other question. If we add the JDK path first, it won't affect our use of MinGW path, right? No, not at all, because the way we add the path is you add a new path, and if you look into your path variable, it append all the binaries that you are adding there. So MinGW should still be there. Yeah. Okay, good. So I hope this shouldn't take like 10 minutes, right? So, but you will have the video, you will have the detailed instructions, and hopefully the transition should be very smooth. So now let's look into the lab itself to see what we need to do, right? So as usual, what I will be doing is, let's close these unit tests. I will be looking into the starter code. So you will be given this starter code in the Get repo, and as well as the PDF document to make sure you guys understand what you need to do. So let me go to the file. Okay. So simply, I guess we have done something that is very similar in C of dealing with matrices, right? So in this lab, it's all about matrices. So we need to create 2 classes. The main idea is we need to create 2 classes. The first one is a general matrix class, and this matrix class has some methods that deals with the matrix: add elements, set elements, get elements, the things that we were discussing in lectures. So going through the questions one by one, we will start by discussing the matrix class and then go to the other one, which is the upper triangular matrix class. So what is the matrix class? You need to define a class that has the following. So let me write here to make sure you guys are following. So these are your, what we called previously your instance variables or member variables, right? Those are the variables you define in your class. As you can see, similar to what we discussed in the previous lecture, those has to be private in order not to enable or to expose them to the outside world, right? And simply, for a matrix, what do you need as a variable? You need the number of rows, columns, and then the array that is really storing the values of the matrix itself. So there are three things: a number that is representing the rows, a number that is representing the columns, and a 2D array which is the matrix itself. Good. So these are the member variables. All of them are private. So now comes the methods. The first method that you need to deal with, which is an application to Wednesday's lecture, is constructor. You need to write at least 2 constructors. The first one takes as an input, as you can see here, the constructor has the same name as we discussed in lecture as the class itself, which is matrix. And then it takes 2 inputs, the number of rows and columns, because constructors are called, if you remember from the lecture, are called directly without you don't need to invoke them. They called when you create an object, and when you create an object, you can pass the number of rows and columns, and then the matrix will be created for you with the correct size. Good. This is the first constructor. The second constructor is, instead of passing the number of rows and columns where you set all the elements to be 0, you pass a 2D array that simply represent the matrix itself. And in this case, you create the matrix according to the array that you received as an input. Has the same number of rows and number of columns. Any question with regard to these 2 constructors? Or any questions so far with what we need to do? Okay, good. So we create a matrix class that a number of rows, columns, the values are stored in an array, and then we create these 2 constructors. You need to implement these 2 constructors. For the second constructor, Muaz, that's correct, the matrix itself. So constructors are for initializations or setting values. Then you start doing the setters and getters, the things we were discussing in the previous lecture as well. So the first one is get element, and get element function simply takes the index of this element, the row and the column, through I and j, and returns the element that you want to read, right? What if those inputs I and j are out of bound? Then this function has to throw an exception. And this is one thing that is new in Java that we didn't have in C. In Java, there is a built-in mechanism to give errors to the user. So we throw an index out of bound exception if I and j are not there, right? And I will show you in the code right now how we write this as part of the function. Good. So simply get element pass row and column number, get back the element if it exists. Good. Okay, perfect. And then this is the getter. What about the setter? The setter do exactly the same thing, but you get the index, row, and column, and a value that you need to set the element to it, right? For example, if I'm passing 2, and then let's say 1 and 3. In this case, I want row 1, so 0, 1, 2, 0, 1, 2, 3. I want row 1 because this is the row. And then column 3, which is this one, I want this element to take this value, 2, right? So I'm setting the element in row 1, column 3 to the value of x, which is 2. This is how set element works. And why it returns Boolean? Because you might end up finding that the I and j are not really part of the matrix, out of bound. Then in this case, you return false. So simply, if the process is executed correctly, you return true. If it's not executed correctly, you return false, right? Are we good so far? Okay, then these are setters, getters, constructors, the easy things to start with. And these, by the way, are the default thing you need to do for any class you create generally. This is a good professional programming way for OOB. Once you create a class, define your constructors and setters and getters. But then what are some of the actual methods themselves? The first one is we want to create a function that is called copy. And simply what copy does, it returns to you a copy of the matrix. This is why the return here is of matrix class type. And this is the first time we see that a function can really return a class, right? So remember in C, we have discussed that, and you do this in the current lab already, you can return a structure from a function, right? Why? Because structures in C are just normal types, but these are types you define yourself. The same thing for classes here. You can return a class from a function, and this is what this copy do. Simply, if you just call the copy method, it will return to you a copy of the current matrix, right? What we mean by deep copy, it means another version of the, like it's not just like, for example, referencing it by value. So it doesn't refer to the same memory place. It has to be a complete other copy. So for example, if your current matrix object is stored here, this is M1, for example, if you call M1.copy, it should create another copy, M2, in another place in memory, a completely separate one, another object, right? Any question? Okay. And then add to. So add to takes as an input a matrix, and then it adds it to the current matrix. So this is why it only takes one matrix. And we will be discussing this in today's lecture, hopefully, which is there are different type of methods in Java. The first one is, as to this one, it really operates on the current matrix, which is the this, like the this reserved word we have, or the keyword we have used in the previous lecture. Simply all the function, all the method is doing is something related to the current object, so it takes no input. Or there are methods where it needs to do a certain operation with the current object and also an input object, similar to the add here. I want to take another matrix object and add it to my current, and then it returns nothing. Good. And simply what it does, it adds this input matrix to the current matrix and places the result into the current matrix. And then, yeah, let me see if there are questions before I proceed. The input is the matrix directly. Oh, I guess I already answered this for the constructor. Jan, how does Java has any method that returns the length of list? I'm not sure what you mean by list, Jan. How? If you mean array, then yes, the array itself has something that we have used, I guess, in previous lecture already, the dot length member function, which is or member variable, which gives you the length. That's correct. If you want to know the number of rows and columns here, for example, you can write your own. You can write your own function or method, and we have this instruction towards the end of the lab. If you want any helper methods that tells you, for example, what are the dimensions, the current dimensions of the matrix, you can write it simply by just returning rows and columns, right? Good. Another thing, I guess, let me see. Sarah, how do we copy the matrix without aliasing? I'm not sure what you mean by aliasing, Sarah, but maybe it seems you are coming from the Python background. So simply, if I create two objects, let's say I have two variables, X and Y, right? And then I want to copy the value from X to Y. Then you say, for example, Y equal X. Now that means Y is another copy of X, but it's a separate copy. This is what we mean by creating a copy of the matrix. You create another object. For example, from the main, or whenever you test this, I want to do something like the following. Matrix M2 equal new matrix, but just declaring it, and then say M2 equal M1 dot copy. And then what this function should do is copy all the elements from M1 to M2, right? This is simply what is meant by copying the values, right? Taking them one by one. Abigail, where it says the retail message of the exception, do we have to print something? I will come into this, Abigail, when I go to the code, right? But to answer your question is, in most of these methods, as I was saying, Java has its own way of throwing exceptions, and simply you want to print a message to the user. And we really do use this message in the JUnit testing to compare whether, for example, if there is an invalid input, are you printing or not printing? Are you returning the correct exception message or not? And we compare the message. Then you have to make sure, my instruction is you have to make sure you exactly match the message we use in the test file. And I'll show you some of these right now, right? But you don't have to print it. You just have to throw an exception. It's called throwing exception. This is going to be the return from the function. We will come into some of these low-level details now, but I just want to first explain the logic behind the lab, right? So copying a matrix and then adding a matrix, then submatrix, and also it returns a matrix here. What is submatrix? Simply, let me make sure I can open a whiteboard and show you an example, because starting forward, maybe it's good to visualize things. Okay, here, new whiteboard, and then share, and then Microsoft whiteboard. Okay, good. So I hope you are seeing my whiteboard. So assume I have a matrix like this. Any value, I don't know, like 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Any value. It's a 3 by 3 matrix. This submatrix, so I have a function that returns a matrix type. It's called submatrix. And sorry, it takes two values, int I and int j, where I represent a row number and j represent a column number. And simply what I want to do is assume, for example, I'm calling submatrix whose I equal, I would say 1 and int j equal 2. So what it does, it goes through this matrix from 0 to the row number I'm giving as an input and construct a new matrix. So this matrix output, this is the input, which is my current, this is my current object, which is somehow you can look into it as an input that you are operating on. The output should be returning a matrix that takes all the elements of this matrix starting from row 0 to this row and from column 0 to this row, which means it should have 2 rows and simply 0, 1, 2, 3 columns, right? So it takes row 0 and row 1, and that means 1, 2, 3, and then row 1 is 4, 5, 6. This is the submatrix you need to return. Why that's the case? Because it took from row 0 to row 1 and all the columns basically, right? Let me give you another example. What if I take, I am passing I as, let's say 1 and also j as 1. In this case, it should be a 2 by 2 matrix because you have 0, 1, 0, 1. You take the first row, which is row 0, and then you take also from column 0 to 1. So you have to take simply this and this, which is, this is your submatrix. And this is 1, 2, 4, 5. Does this make sense? Or there is any question? Do you understand what is the requirement here? So simply I'm taking two indices, row and column, and I'm returning the submatrix starting from row 0, column 0, up to the row and column that I input to the function as a parameter. Any question? This seemed good? Okay, good. So this is the submatrix, and it returns a matrix type because at the end, this matrix or this one or this one are really still of matrix type, right? So how I would do it, how would I implement it, just to give you a hint of how you should start. Simply, I need to return a matrix type. That means I need to define or declare and create an object of matrix type. I can call it submatrix, for example, and then do a for loop from the beginning to the numbers I have as an input, and then copy the values from the original matrix, which is my current matrix, into the output matrix that I want. Very simple, I guess. But there is one thing I didn't pay attention to. There is something that might end up being wrong in this implementation. Like, do you think? Do you have an idea what might be this? What do I need to do extra to make sure it's a correct implementation? This is making a new matrix, right? With a different memory place. Yes, it's different memory. That's correct. Yeah, Sarah, that's exactly correct. Check if I and j are valid. Like, because for example, a user, remember these I and j are coming from the user. So what if they are out of the bound? What if, for example, I have 3 by 3 matrix, but I passed 4 and 4, right? So you need to check for that. Otherwise, you will go out of bound exception in Java. Good. And there is a detailed message you should print if this happens, right? Okay, good. So this is submatrix. So for example, here it tells you the method should first check if I and j are within the required range. If not, then it should give you this output message, submatrix not defined, right? So you should write for your code such that if I and j are out of bound, you should return this message as throw exception. Good. Then the sixth method that I should implement is upper triangle, and we have, if I remember, we have done this already in lab 2 to check whether a matrix is upper triangular or not. And what is an upper triangular matrix? It's simply a matrix that all the elements below the diagonal are 0 elements. For example, if you have 3 by 3, this is your diagonal, so all these elements are 0. This is an upper triangular matrix. If you have any value here, that means not upper triangular. What if it's not a square matrix? So for example, 3 by 4. In 3 by 4 matrix, your diagonal is still 3 by 3. Then all these elements are 0, and this is still an upper triangular matrix. And your code should really work whether your matrix is square or not. Good. This function, as you can see, it just takes no input, which means it operates on the current object. And it returns a Boolean, true or false, if the current matrix, when I say current, is the object that I'm operating on, right? If the current matrix is upper triangular, it returns true, otherwise it returns false. Good. Oh, if you throw an error how, then you will not return, right? Eclipse just doesn't, like, you don't return anything. Ishmael, you can print stuff if you want, but as I said at the beginning of this tutorial, simply you don't need to print anything unless you are instructed to do so, and avoid printing as much as you can, because really printing for debugging purposes is not the correct way of testing your code. You should use unit testing for this, and this is the whole thing behind the environment we're using. Good. Then the seventh function is sum. What sum is doing is something that is very interesting. It takes an array of matrices, right? Remember, a matrix is a class, and you can construct arrays of classes similar to what you do in lab 3, which is arrays of structures. And then it sums all the matrices, so it adds all the matrices together. For example, if your matrix array has a matrix A, B, C, it adds all of them together into a matrix D, and it returns D. This is why it returns this matrix as an output, right? So it takes an array of matrices as an input, and it returns a matrix that is composed of all the sum. You know that for sure to be able to add two matrices, their dimensions should match, right? This is simple math, right? So what if the dimensions don't match? Then in this case, you have to throw an exception, right? And then simply toString is transforming the matrix into a string that is composed of the values of your matrix. If you have something like this, then you should construct a string that has 1, 2, 3 in a line, and then 4, 5, 6 in a line, 7, 8, 9 in a line, and then you return that string, right? Good. So this is for the matrix class. Then we will look into the second class of the lab, but let me check questions. Katie, for the 4x, then would it still be right if the bottom line was not 0? Then yeah, if the bottom line has any element that is non-zero, like for example here, if you have a 4 by 3, I guess you are referring for the 4 by 3 here. Your 4 by 3, that means your current, again, 4 by 3, you take the least equivalent square, which is 3 by 3, which means this is your diagonal. If you have any non-zero element here, that means it's not an upper triangular matrix, right? So you always look for the diagonal, and then you check everything afterwards. How you know the diagonal? It's simply the min. If you have number of rows and number of columns, the min of both is really your diagonal, because the diagonal definition is where the number, like the row equal to the number of the column. For example, here, this is part of the diagonal because the row is 1 and the column is 1, right? Here, the row is 2 and the column is 2. So the formal definition of a diagonal element is an element where its index of row and the index of column match, right? Good. Okay, so we already defined what is an upper triangular matrix. Now we write another class, because this lab also works on how classes interact together, right? So you write another class that is called an upper triangular matrix. But really before this, let me jump into the code. I want to connect this information with what you will see in the code, right? So here, this is a matrix.java starter code you would have. You will find that I'm already giving you all the prototypes for the methods, so you don't need to care about them. I also give you like the member variables, so you don't need to care about them. And simply, this is the constructor. This is the second one, which is takes the array. This is a get element. Here you see how it like you if you write a function prototype like this in Java, it throws the it tells the compiler that this function, if it doesn't work properly, you have to throw an exception, and then you should write your code accordingly. Like if for example I and j are out of bound, you throw a Java exception according to a certain syntax that is easy to do. Good. And then setting elements, matrix copy. Here, for example, matrix copy is defining, as I was telling you, you already get the copy, like it's already declared for you, but really it's declared using the wrong size, and then you return the copy. So you have to fix this size and then copy all the elements from the current matrix into the copy and then return the copy itself. Add to, you should add the matrix M into the current matrix. Sub matrix, as we explained, also you get it created for you, but with the wrong dimensions. So you have to check for this. Yeah, so this is, I believe, what Yanha was asking about. I'm already giving you 2 helper functions you can implement if you want, which tells you how many rows you have and how many columns you have, right? And then is upper triangular operates as we explained. Here I'm returning true by default, which means it doesn't work as intended right now. You need to do the check and correct the return. And then the sum is going to add all the matrices in the array. And then I'm calling the object that I'm returning super matrix. Again, you should put the dimensions correctly and then do the sum, put it in the super matrix, do the actual implementation. Good? So let me go back here and check for questions before we go to the second class. And we wouldn't have much time, but let's see. How do we throw the exception? So I would say, I'm not going to say this right now, Karina. Let's wait for this right now. We will see this in lectures, but really it's a single line. If you look it up anywhere, you'll be able to know it. It's just a simple to throw exception. It's a simple syntax in Java, and I believe I have one example about this in lectures. So let's leave this for now. For the message for the throw exception, do we print the message? Yeah. So again, this I guess also compounds on Karina's question: how really you write an exception, right? You know what? Maybe okay. Let me just show you one example, and then hopefully. So can I ask you, what screen are you currently seeing, the Java one or the PDF file? Okay. So although this is my implementation, but let me show you one very simple example here. Where is throw exception? Here, for example, okay? So here, get element. I'm really checking, first of all, whether I and j is within the bound. If so, I do it correctly. Else, this is how you throw exception. Use the reserved word throw new, and then this is the exception type, which is really you are given already in the function prototype. And then you open 2 brackets, and then you write the message that you want to throw, right? So this is simply how we throw an exception. I believe if I didn't have an example like this in the lecture, I might also put one example in the lab document just to make sure you guys don't suffer finding it out. But simply single line, right? Throw new, the name of the exception. These things are standard in Java, and it's exactly the same name that we have in the function prototype, which is given to you. And then you open brackets and you write the message that is also given to you and is used in the JUnit test cases. Good? Okay. So for the upper triangular matrix, simply it's another class, but this class is a little bit different. It only operates on upper triangular matrix or matrices. And because this is an upper triangular matrix, we really don't need a 2D array to define it. So simply, we just use a single dimensional array for the upper triangular matrix, because simply the way I can write it is, maybe I should hop again to the whiteboard. Let me do that. Okay, so what is going on? We have another one. So I guess you're able to see the whiteboard. So please say otherwise if that's not the case. So if I have an upper triangular matrix like 1, 2, 3, and then 4, 5, and then 6, it's a 3 by 3 one. And the upper triangular matrix class only operates on square matrices. So you don't need to care about the cases that I discussed in the matrix class. It's only like a square, which means the number of rows equal to the number of columns. Here is 3 by 3 upper triangular square matrix because the diagonal everything afterwards is 0. Simply to store this, I don't need a 2D array because I know how things are aligned, right? So the way I can write it is to say, I might write the like row 0, column 0, something like 1, and then 2, and then 3, and then 4, and 5, and then 6. Given that I know it's a 3 by 3, that means the first one is composed of 3 elements. The second one is composed of how many elements? 2. And then the third one is only 1, right? So this is, if I just write an array like this, and I'm telling you this is an upper triangular matrix, you can really reconstruct the actual matrix from it, right? So this is what the lab document is saying here, is we can efficiently implement or resemble an upper triangular matrix by using only a one-dimensional array of this size. What is this size? For example, in the n by n, here is 3 by 3. How many elements we needed for this one? 3, 2, 1, right? If you add them up, it's 3 plus 2 plus 1. This is really a series, right? If you have an n by n, it should be n plus n minus 1 plus n minus 2, which reduces to the current series, right? So simply, you need only n multiplied by n plus 1 over 2 array size, right? If n by n is your square matrix. Good? And then you implement it in the way that I just showed you in the whiteboard. Good, this is just defining how we deal with the upper triangular matrix. If we go to the code, here, you find that I defined n, which is the input. Oh, this is the implementation. Let's not do that. Here, I defined n, which is the size of the matrix, and I only need a single dimension, not row and column as the full matrix, because this is a square matrix. You only need one n because it's n by n. And then a single dimensional array that is going to represent the upper triangular matrix, right? And then we have the constructors, the things that we will explain now in the lab document. Good. So upper triangular matrix, you have the following two constructors, another two constructors. The first one takes n as an input, and then it initializes a 0, like n by n upper triangular matrix of all 0 elements, right? And then the other one, it's almost the same mentality of the first class. Like one takes the dimension, initialize things to 0. The second one takes an actual matrix, upper triangular matrix, and then places this into your array, right? One of the things you need to take care of here, and really this is the main point of having two classes, is, as you can see, the input parameter for this constructor is not of type upper triangular matrix, it's of type matrix, right? Which means this upper trem thing is really going to be a 2D array, right? And then you have to transform this from the matrix representation into the upper triangular matrix representation, from a 2D array into one-dimensional array, right? You have done exactly the same thing in the C lab, but like using different coding way, no classes, nothing, but simply you transform it an upper triangular matrix, like a normal matrix, into an upper triangular matrix, right? Is there any question here? So how to do this? Simply first, you need to check whether this matrix input is an upper triangular or not, because if it's not, you cannot really transform it into an upper triangular matrix class. How do I check this? Remember, you already have a function or a method you implemented in the first class that is called is upper triangular, and it tells you false or true whether it's upper triangular or not, right? And then if it's upper triangular, it's represented in a 2D array. So going back here, it's represented in this format. So you can think of this as your matrix class that you take as an input. And then you need to transform this into this representation, which is the upper triangular matrix representation. Good. I know time is over, but I want to give you all the things that I need to say about the lab. So Let's stay for maybe 5 extra minutes maximum, okay? Is there any question here about this transformation? Because the idea of transforming a class to another class representation is really key in all the coming methods. So if you get questions, please ask. Okay, good. So you guys are quite quiet today. Will this be covered in lecture? I'm not sure what you mean. You mean like Sky, you mean transforming classes, dealing with 2 different types of classes? Well, theoretically, yes, but what we do in tutorial is really focusing more on the lab question itself, right? So this is the implementation side. This is not new information, so it's not something that is you need to wait for a lecture to be able to do it. It's simply applying what we learn in lectures about classes into the lab. So no new information is really included in this lab. Otherwise, you cannot start on Monday, right? So all what we cover here is this something we already covered in lectures. In coming lectures, we might be touching in more details, but no new information is in this tutorial or in the lab, right? Okay.
Hello.
Yeah.
Can I ask a question about the lab 3, about the Moloch?
So let's not break the flow anyhow, and then maybe at the end I will take a few questions about it, just to make sure we are all focusing on the coming lab, and then I can take questions about the lab 3 at the end. Yeah. Okay. About triangular matrix, we already discussed the 2 constructors. Now let's discuss the methods themselves. We have a similar method to get element. This is already explained in the matrix class, so it's a very similar one. Get dimensions returns the number of rows of this matrix. Set element is exactly the same way. You take the element and you also take the row and column. Something you see here is we are dealing with the upper triangular matrix class as also a matrix representation. So we are passing number of rows and number of columns as an input, while internally we implement it as an array, right? This is compounding on what we discussed in the previous lecture, which is really how you implement things should be hidden from the actual user use, right? So I'm telling the user, I'm giving you an upper triangle matrix class, which means as a user, I should deal with it as a matrix. How do you implement it internally? Whether you do it efficiently through a single dimensional array or 2-dimensional array, I shouldn't care, right? Does this make sense? So for example, I can take exactly the same interface with all the functions and change the 1-dimensional array to a 2-dimensional array, and everything should work as intended, right? So you need to pay attention to this point, is all the interface functions are dealing with a 2D matrix, while internally you implement it as 1D, right? Okay, and then full matrix is doing really the other way around of this thing. So we said in the constructor, you take a matrix class, a full matrix class, a 2D one, and you transform it to the upper one. A full matrix method. So this is the constructor. Let me use a different color here. So this was the constructor. Now, calling the full matrix method, it takes no input parameter because it operates on the current upper triangular matrix, and it returns a matrix class, which means its input is really an upper, and it returns the full matrix. So you need to take this 1-dimensional representation and put it into a full matrix representation, right? How to do it? You simply need to define or declare and create a matrix class, and then copy all the elements of the upper triangular into the new matrix class, and then return this matrix class. Good. Yeah, sure, Sky. This is an important question. As I said in the previous lecture, the way you should approach the labs and the lectures for Java and C, and usually for the whole course, is you start by the examples in the lecture, maybe some of the practice questions as well, and then we will discuss the lab. The lab might seem for you right now a little bit involved because I believe most of you didn't yet start doing anything in Java. But once you start it, you will find this really much easier than lab 3, for example, right? Okay, print 1D is just, so this function will be, this method will be removed, so forget about it right now. ToString is similar to the other one. You really create a string, okay, similar to the one that in the matrix class. It takes the current matrix, upper triangular matrix, and then creates a string that has all the elements of this matrix. Good. And then the last two, and we will conclude by this, and then I will take questions. The last two is get determined. Do you guys remember what is the determinant of a matrix? Like simply from the math, the determinant is the product of all the diagonal elements, right? So if I go here, and it has many applications in matrix arithmetic operations, right? If I have, for example, this matrix here, this is the diagonal. If I multiply all the elements of the diagonal, this gives me the determinant of the matrix, right? So let me go back here. So this get determined is really returning an int, because all the elements of the matrix is an integer, and then if you get their product, it returns to you an int, right? And then finally, this might be, I believe that as usual, you'll find the lab is building, and then the last question is something that's a little bit involved, right? So this method, you need to what we call do an efficient solving of an equation, right? Because one of the most common applications of why we say triangular matrix, I mean, it's something that for you would seem an overhead, right? But really it's not, because once you observe in any math operation or machine learning applications or whatever, once you determine, you kind of detect that a matrix is upper triangular, all your math operations can be much faster, right? Why that's the case? Because you know almost half of the matrix is zero. So if you are multiplying stuff, it's just zero elements, right? Here is showing you one application of this, which is we'll try to solve this simple equation of A multiplied by X equal B, where B is a scalar value, X is a one-dimensional vector, and A is our upper triangular matrix, right? And then we need to solve this equation such that it gives, so simply, I believe what you would have at the end is the X itself, right? So you would have the B, which is a scalar value. Oh, sorry, this has to be a vector as well, because if you multiply this by this. So for example, if I go to the whiteboard, let's say I have this, also this upper triangular matrix. I have here 1, 0, 0, 2, 4, 0, 3, 5, 6. And then I have x1, x2, x3. This would be equal to, you take this, multiply. So this is 3 by 3. This is 3 by 1, which means you would have a vector that is of 3 by 1, right? And simply, the first element here, B1, will be the multiplication of this over all the elements. B2 will be the multiplication of this over all the elements, etc., right? So what you take as an input is this P, this A matrix, and then you need to solve for X, your unknown, right? And what you are required to do is to do it in an efficient way by leveraging the fact that you know it's an upper triangular matrix where most of the elements are zeros. So the hint here, for example, if I go back to this example, the last one, I really don't need to multiply this by this and this by this, right? I only need to multiply the last element by the last element because I know the first two are zeros, right? What about the first one? I already know that this is 0, so I don't need to multiply this by x1, right? So the hint here is just skip the 0 elements in your matrix, and this is an efficient way of solving it, right? So by this, I am done, and let me take questions if you guys have questions. I guess, Yan Hao, you had one, so please go ahead. So before lab 3 questions, is there any question related to this lab? Yes, Arjun, that's correct. The original class inherently implements everything as a 2D array, while the triangular one is operating in a 1D array. Are there any other questions in this lab? Okay, so let me take your question then, Yan. How about lab 3?
Yeah, just about the free stuff. Like in all of those questions, you need to return something, right? And then if you do the Like if you do the return, you can do the free. But if you free, it doesn't return anything. Like I'm just wondering.
Okay, yeah, that's a good question. So well, I would say what you said is not generally correct, because for example, assume I'm returning something that was like, I will give you one example in general, which is I allocated an array of memory, and then dynamically inside the function, and then I calculate all the summation of all the elements of this array, place the summation in another variable, and then return this variable. In this case, outside of this function, you really don't need the memory allocated to the array at all, because you already reserved the summation values into another variable. In this case, you can simply free inside the function, right? So it's not generally correct that if you are returning something from a function, you cannot really free inside the function. The general rule is if you don't need the allocated memory outside the function, then you can free inside the function. Otherwise, you should free on the function that is the caller function, which is calling this one. Does this answer your question?
So you mean like we are letting one another like variable equal whatever we
Oh no,
malloc?
I mean, I just give an example. No, so you don't necessarily need to do this unless, so let me open the lab, because I believe talking in a specific example would be much easier, right?
Yeah, just a question one.
Okay, that's lab 3. Are you able to see the lab document?
Yeah.
Okay, question 1. Okay, in this case, you want to return the array that is dynamically allocated, correct? So in this
Yes.
case, you really cannot destroy it inside the function, right? Because otherwise you would lose the created string.
Yeah. So should I modify the testing case to
You
add...
can, yeah, in this case, if you want to free after you finish the test case, yes, do that, right?
Let
But
me-
I guess what I said in the previous tutorial is really in the first, because this is a single string, it doesn't really matter to free. I'm not very worried, but I just want you to stick to a rule that anything you do a malloc, you free, right? So yes,
see.
please do this if you want. But otherwise, if you didn't do it for the test case that I gave you and you do it for your own test case, that's also okay, right? I'm not sure. So let me not confuse you. Yes, if you want to modify the test case to free, do that, okay? Does this answer your question?
Me?
Yeah.
Or Arjun?
No, your question.
Oh yeah, it does answer my question. Thank
Thanks,
you.
Anil. Thank you. Arjun, are we required to free the memory? Like I know this good. Yeah, you are required to free the memory, Arjun. Any memory you allocate, free it. Otherwise, you would be losing marks, because even before losing marks, your system might crash, right? If you are overloading your operating system.
I had a quick question about freeing the memory as well.
Yeah, go ahead, please.
Because you said for the first question, we didn't have to worry about it, right? Just because it was the one array.
Yeah.
And then for the second one, are we fine just to free like C list in the test cases, or do you need our functions to actually free them within the functions as well?
Yeah, good. That's a good question. I guess this is related to what I was discussing with Jan Hao right now, which is, let's say, for example, in this function, right? I'm writing a test case for this function. If you free the list that you created, which is this list, if you free it inside the function, you really cannot return that, right? So it will not even work. So the rule that I want to give you is, you really malloc and free gives you the control of not just creating memory and freeing it, but also when you can do that. You can do it according to your choice. There is no one correct rule here. If you need, as far as you need the memory that you allocated, then don't free it. And the example is like this one. If you are writing a test case that calls this function, if you free the memory inside this function, really you lost the return, right? Because outside the function, you don't have the memory allocated. You no longer have the list. So in this case, you should be freeing inside the test case. Good. Okay. While there are, let me pick another example that, let's say inside this one you already don't create, because you already get this created in the test case and should be freed inside the test case. But let me say there is an example where you really you need for some reason to define a memory inside your allocate a memory inside your function for some reason, right? But then this memory, you don't need to return. You for example, you define it, the example I gave Jan, how first you allocate an array, you operate on the array, you do some calculations, and you only care about this calculation to return. In this case, it's safe to free once you finish this function, because you no longer need the array data itself outside the function. You only need what you calculated, right? So the general rule is, once you see you no longer need the data allocated, free it. Whether this is inside the called function or the caller function, which in our terminology here is like the question function or the test case function, it will really depend on what you do by the memory allocated, right? Does this make sense, or it makes things even harder?
Yeah, but as long as we have it freed, that's okay then? Like,
yeah, that's
if
correct.
We're not particular about
that's
it?
correct. As far as when you free it, the program still works correctly, right?
Okay,
So
yeah, it's still running.
this, then yeah, correct.
Okay, thank you.
Yeah, welcome.
Sorry.
Go ahead.
I may have another way to free it, but I don't really sure did I free it successfully. I just free it inside a function, but after the returned it, I mean, such as the second question, I just free it after the return, and so we still have a clock or malloc we create inside a for loop. So I create another for loop, and to create if the word list is not a none one by one.
So Zawahan, let me ask you one thing. When you say you free after the return, you mean after the return line inside the function itself, or you mean after the? But I mean, this will never get executed then. I mean, remember, a function finishes execution once you hit the return. Anything afterwards is just ignored, right?
Oh.
So you really don't free, right?
Okay.
You see my point? Like in a function, once you hit the return line, the function will return. So anything afterwards is not implemented, right?
Oh, okay.
You see that?
Oh, I see. So I have to free it inside the test case.
Yeah, I believe in all the lab questions, like just from going through it right now, you really just can free in the test case and that's it. If you want to simplify stuff for yourself, yeah, free in the test cases. I don't think there is a way, there is, I would say, a need to care about freeing it inside the function itself. Yeah.
But what if I create another pointer, not a pointer, I create a malloc inside a for loop, and I need to use the data inside this kind of a for loop to take the return, but I cannot free it inside the for loop, yes. So,
well, I mean, if you create it inside a for loop, which means you do multiple mallocs similar to the 2D allocation we had in the lecture, I believe use also, because inside the lecture we also showed how to free this, right? Which is you create another for loop. Yes, that's correct. But you need to do it in a certain order. For example, what we discussed in this lecture is you cannot free the double pointer that you have. So let me quickly do that. So in a 2D allocation, something we have done, which I believe also you should be doing in the lab, is something like this. This is an array of pointers.
Yeah.
Then everyone is pointing to this. And these arrays are the ones we created using the for loop, right? So you cannot free this one until you free all that, because otherwise, if you free this, you lose the pointer to the certain array and you no longer can free. So if you look into the steps we have in the lecture, we go through the for loop one by one to free this. Afterwards, we free the double pointer.
Yeah, I also did it, but I found my mistake. I just freed it after the return.
Yeah, which is like
just
effectively
useless.
Not, correct.
But I still need to free it inside the test case, yes?
Yes, free it inside the, I guess that maybe the simple answer for everyone is just free this inside the test case.
But if for this lab, I didn't free it really well, will I lose mark for the free?
Yes.
Oh, okay. And another question.
Yeah, go ahead.
Such as for the question 3, we need to use a two-way to do the word sort or sort function. I mean, so one is it told me to use insertion sort.
Oh, it just gives you an example.
Yeah. For another way, can I just use similar insertion, but I use a 2D array. The first one I use a 1D, and another one I use a 2D. Can I just use this method?
I'm not sure of. You shouldn't be okay. So you shouldn't be declaring other for sorting. Don't create other arrays to sort. If this is your question, no, don't do this because this is space inefficient. The reason this is saying the first function in C should use insertion sort. The second one, you can use any other type of sort, binary sort or any other. You can look up sorts. The main reason or the main rationale behind this question is to really start putting you in the steps of sorting algorithms, right? Insertion sort is a simple sorting algorithm. If you look how it works, it's very simple. And then, but it operates on the array itself. You don't create another array because if you create another array, this is space inefficient. So for this question, don't create any other arrays to sort, right?
Yeah.
Sort in the array itself.
Yeah. I know. But my question is, here's a two function. I need to write it. The first one, it gave me an example. For the
the first one is using insertion sort. The second one, you can use whatever method you want, other than the insertion sort for sure. Otherwise, the implementation will be the same, right? So it just tells you, select any other sorting algorithm than the insertion sort and try to implement it. One of your choice, right? There are like many, right?
So I cannot use another way to write the insertion sort.
Yeah, sure. It has to be a different algorithm.
Okay, thank you.
Yeah. Bubble sort, like binary sort. If you look sorting algorithms up, there are some of the very simple ones, right?
Yeah. Thank you.
Thanks.
I have a quick question. I'm still a little confused about the freeing. So we can't, because like if a array or dynamically allocated array is allocated within a function, because it's local to that function, we cannot access that exact array outside unless it's
that's not correct, Arjun, for the following reason. So here, for example, in this method, which is the main method, you create the list inside, right? I guess this is the one you're referring to. Here, you're returning this pointer, which is really pointing to the memory allocated. So you already have the pointer. So outside.
Yeah, but it returns the double pointer.
Well, yes, the double pointer is really the key for everything, right? Because inside the double pointer is showing you every single other point. I mean, for this 2D array, this is one of the neat things about 2D memory allocation is once you have a single pointer, you can really access everything here, right?
Okay, so in order to free that, we can't just free the return. We have to iterate through the return.
Oh, yeah, sure. Please, yeah, as I was saying to Zauhan right now, like in the 2D memory allocation and deallocation lecture, we had an example of how to use this one through a for loop. Otherwise, if you free this first, you lose everything here. This is not freed. So what you need to do is to do a for loop over these pointers, free these first, and then free the double pointer.
So this has to be done in our test cases.
This case is correct.
Okay, and if we don't do this properly, we lose marks on it.
Right now, I believe this was the original intention, and I kept saying this like 3-4 times in tutorials and lectures. But right now, I might see that today is the deadline. It might not be clear for others if it's not clear for you guys. So I might reconsider that. So I will go ahead and read what are the exact instructions I had in the document. If it didn't state clearly, I might reconsider that, right? But
right, like I understand the importance
from grades,
of doing it.
Exactly. Aside from
tricky.
grades, make sure you do it. Otherwise, things are not really very safe, right?
Yeah. Okay. And then unless it's returning a pointer or double pointer to an array, we should be able to free within the function.
Exactly.
Is that what you were saying?
Exactly.
Okay.
Exactly. Because otherwise, you don't have access to this memory outside the method, the function anyway. Yeah.
Okay. And if the function is passing in a list or like array or something like that, but it's not returning that, then we don't have to worry about freeing memory that is already created by
outside. Exactly. For example, this one here. It has the list passed in from the test case. So the test case function is the one that really should care about. So whoever creates, so this function should really worry about like freeing this, right?
Right. So I don't have to be responsible for if we're doing any of the inputting, like the setting functions, I guess. I don't have to be responsible for clearing or freeing the arrays that are passed in as it's only whether if I'm creating it within the function that I have to worry about freeing.
Correct. Or
Okay.
or maybe if you're writing a test case and you are creating it, then you should worry as well. Yeah.
Right. Right. Okay. Okay. Thank you.
Good. Thanks, Arjun.
Sorry,
Oh,
I may
sorry, go ahead.
misunderstand. If you mean if the function or the number didn't return, so I don't have a responsibility to free the number that is didn't return.
No, what I was telling Arjun is here, for example, in the input grades function, it takes the student list as an input, right?
Yeah.
Which means this list is created outside this function, right?
Mhm.
So this function shouldn't care about deallocating it. So what you should do is really deallocate it or free it in the test case that created it, right? So again, this takes us back to the rule that if you are confused, do all the freeing inside the test case.
Yeah.
Good.
Okay. Thank you.
Okay, welcome. Is there any other question? Okay, thanks everyone, and I will.
Sorry.
Go ahead.
I actually do have a question.
Go ahead, Zain.
It's just I think it's the last part, the last part of question 2, where it tells us to invoke withdraw 3 times. Do we have to do that stuff, or is it?
No. So
Okay.
simply just the general rule we have for all the labs is any function you write, you need to test it at least once in the test cases.
Right.
Yeah.
That's it.
Okay. Yeah. Good. Thanks.
Thank you.
Yeah. See you all in the lecture soon. Bye bye.